do this again. So what does it mean for a function f of x to have a limit L as x approaches a? So as x approaches a, what does that mean? It's getting closer and closer, right? So let's start off with that. As x gets closer and closer to a, what's happening? Well, let's look back here. It says the function f of x has a limit L. So what does f of x represent? Y. It's a fancy way of saying y, right, for a function. So as x gets closer and closer to a, what's happening to y? Bigger or smaller? It's kind of doing the same thing as x. It's getting closer and closer to something. What's the y value going to get closer and closer to? Got another variable over here, L, right? So as x gets closer and closer to a, y gets closer and closer to L. So as x gets closer and closer to a, y gets closer and closer to L. How would you write this as a mathematical equation that represents the statement above? So this is getting at the notation, limit notation. How do we write this without having to say all this stuff? Anybody remember how to write that and how that kind of looked? Something with arrows. No, I think that's a little, I mean, you may have seen it that way, but there's a more condensed way, I think, than what you're thinking. There's x approaches, we'll just use this, a, right? What's on top of this? The limit, LIM. So the limit as x approaches a of that function, so of f of x equals L. So to read this, it's kind of what we see up here. The limit as x approaches a of f of x equals L, or limit of f of x as x approaches a equals L. Kind of a simple way to look at it, as x gets closer to a, f of x gets closer to L. So this doesn't have an arrow, but it's kind of an easy way to think of it. As this value gets closer to this value gets closer to this one. All right, so that's limit notation. Most of the time you'll see it, limit as x approaches some number of a function equals what? You have to figure that out. You're figuring out L. Next question, does the value a have to be in the domain of f of x? So first of all, what's the domain again? It's an algebra question. Domain is the x values, right? What x values can go into this function? What x values can we use and put into our equation? So in most cases, when we talk about domain, we're looking for the ones, which ones don't work. Because most of the time, most numbers do work, and there might be a few that don't. All right, so does this number a, does it have to be in the domain? So I don't necessarily expect you guys to remember this one, but the answer is no. It does not have to be in the domain. And I'll show you an example. If we have a picture, it looks like this. So we have a parabola with a hole in it. Let's say this is A. And where the hole is has a y value of L. Well, A is not in the domain, right? We can't put A into the equation because when we put it in the equation, we get nothing out. That's why we have a hole. Right? So A is not in the domain, but the limit exists. Because as we get closer and closer to A, as our x value gets closer and closer to A, the y value is getting closer and closer to L. All right, and the big thing here is that it has to happen from both sides. So if you look from the left side, as our x value gets closer and closer to A, the y value is getting smaller and smaller and approaching this hole. From the right side, our y value is getting smaller and smaller and approaching the same hole. That hole happens at L. So here, the limit as x approaches A of our function is L. And A is not in the domain. So a big thing to remember with a limit, you don't have to actually get there. It's about getting what you're approaching, what you're getting closer and closer to. You may not reach the point but it's what you're approaching that matters. Right? But it's what you approach that matters. So are you approaching? Are you getting closer and closer to something? It doesn't matter if you get there. It just matters what are you getting closer and closer to. All right, so with limits, you don't have to get to a point. It's really not the destination, it's like the journey. What are you getting closer and closer to? And then the last part here, does f of a have to equal L? Well, no, right? We don't have to have an f of a. Here, you put a in, you don't get anything out. Another option would be, let's say there was a point like right there. And we'll see some problems like that, where there's a hole and then just kind of a random point. Well, f of a is equal to this. That's not the same, as our limit. Right? Our limit is down here. The point and the limit don't have to be the same. And that's something we'll talk a little bit more about as the